Kia ora koutou. I hope you're all having a good start to your week, and I'm very sorry I can't be with you. Due to taking a COVID test, I have to wait until that comes back before I can come to school. So what we've been going through over the last week is rates of reaction. So we just want to really sort of cap that off by doing a couple of practice problems today, and I just want to run through the basics that we need to do when we're answering a question around rates of reaction. The first thing that we need to be able to do is we need to be able to state what collision theory is. So we're talking about reactions, right? And what speeds them up or slows them down. Now, for a reaction to take place, and this isn't exactly how it happens in reality, but it's a good model. Particles have to collide, so that could be two different chemicals, different molecules. Particles have to collide with the right orientation and with enough energy. And that's what we call collision theory. If they collide with the right orientation, the right energy, then a reaction is going to take place, and we call that a successful collision. And that's really the terminology we need to use. A reaction taking place is a successful collision. If you want more information about this, there's a really good video that I'll make sure I post up on the classroom. So enough energy to collide is also what we call activation energy. So this is also called EA, right? So if these particles have enough energy, which is called the activation energy, then they will you'll have a successful collision. As your temperature gets higher, more particles will have enough energy, because temperature is just the average kinetic energy of particles. So I think reaction rates is something that you covered a lot last year, but there are a few things that we want to go through, okay? So when we're explaining about concentration affects the rate of reaction. So the concentration of our reactants, the chemicals that we're mixing together, right? As we get a higher concentration of our reactants, we're going to have more collisions. If you think if in a room with more people in it, there's going to be more collisions of people, right? Especially if they're running around like crazy. This will mean that there's a greater chance of successful collisions, which will increase the number of reactions per unit time, or rate of reactions. That's an important thing to put in our answers for this, per unit time or rate of reactions, so that we know that we're talking about, it's not the amount of reactions that will happen full stop, it's the amount of reactions that will happen in a given time. That's a rate of reaction. Surface area is also a big factor in this rates of reaction. So it's a similar thing to our concentration. If we've got a low surface area, so we've got a big chip of marble, for example, then only the particles on the outside are available to collide and possibly react. If we've got a high surface area, so if we've powdered up our marble chips, then the particles, a lot more particles are available to react. So therefore there'll be more collisions, and therefore there'll be more successful collisions per unit time and a faster rate of reaction. So that's one of the key things with surface area, which is another one of our factors. So temperature has two effects. When we increase the temperature, we increase the average kinetic energy of our molecules, our particles. So they're more likely to collide with enough energy, with the activation energy. They're also moving faster. So that means when somebody's running around faster, if these particles are running around faster, then there'll be more collisions.